Hello, dear students. Welcome back. Now we will continue with the previous class. It's about monitors and screens and the technology used. And I will remind you that monitors, there are many types of monitors like CRT. Then we have the LCD. Then we have LED. Then OLED. And your mission is to know the definition of each of them as an output device used for what, and the different types, the comparison between them, advantages, disadvantages of each, and to compare between them. And we mentioned before, and we already discussed CRT monitors, cathode ray tube, and it is an old technology of monitors, but still available for people who are dealing with light pen and technical drawings, and they need to work to draw directly on the screens. But it has many disadvantages. Then we moved to the LED, and we told you that LED technology, it is based on using LED. Each pixel consists of 3 subpixels. Each subpixel red, green, blue. All together, the mixing color of these subpixels, red, green, blue, it gives us variation of shading of colors. And we mentioned that this technology, LED technology, the original LED technology, it is not very practical for the big screens like 4K or 8K screens, high definition screens, because the limitation of manufacturing the LED to be very, very tiny LED. I will discuss this. I will show you what I mean by this with the next video. But right now we moved to the LCD monitors, liquid crystal display monitors, and the crystal. I will show you why it named like this, crystal. Also, the video will explain this. But now LCD monitors, it has 2 versions. The first one, it used the backlight with fluorescent big tube fluorescent type, and the newest one, it replaces the fluorescent type of backlighting with a grid of LEDs. That gives the same effect, even better effect, but with thinner monitors. So because the fluorescent tubes considered a large one, so the old version of LCDs, it was a little bit thick, not like the newest one that based on the LED technology, using a LED backlight LEDs, so it becomes thinner monitors. Not saying about organic LED, this is another topic. It is beyond this scope of this syllabus. So the use of LED backlighting gives a very good contrast and brightness range. So we replaced the fluorescent with LED backlight. Before the use of LED, LCD screens used cold cathode fluorescent lamp. So cold cathode fluorescent lamp. Okay, as you see here, so the abbreviation comes from cold cathode CCF, fluorescent lamp. So this is as the usual fluorescent lamp at your home. Okay, essentially CCFL used 2 fluorescent tube behind so it used 2 fluorescent tubes behind the LCD screen to supply the light source. This is the old version of LCDs. The reason that LEDs have become increasingly more popular as the method of backlighting is due to a number of advantages. So, as I told you, we replaced the cold cathode fluorescent lamp with the LED. and this give many benefits over the old one. What is that? LEDs reach their maximum brightness almost immediately. The cathode tube fluorescent, it takes time to give the full efficiency, the full brightness, because it needs time. But LED, it gives the directly maximum brightness. There is no need to warm up. So the old one needs to warm up the lamp. Okay, let's give a whiter light. Okay, so here we have lighter white. Sorry, what's going on? Okay, which sharpens the image and makes the color appear more vivid, more clear. Okay, so the brightness, the whiter light sharpen the image and make the color more vivid. Okay. LED produce a brighter light which improve the color definition. So we have brighter light, whiter light, and maximum brightening. This is the benefits or advantages of LED over the CCFL monitors. Okay, so you have to know that why the LED is better. Immediate maximum brightness, whiter light which sharpen the color, and produce brighter light which improve the color definition. Okay, I think this is clear enough. Let's move. Screens using LED technology are much thinner. This is a big advantage, of course. Much thinner, okay, than screens using CCFL. Why? Because the same lamp considered huge, and when you put them as a backlighting, it will take space, a lot of space. While LED, very small, and it reduces the thickness of your screen. LED lasts almost indefinitely. It lasts forever. This makes the technology more reliable and make for more consistent product. So it lasts a long time. While the fluorescent lamp, there is a limited time for it. LED consume very little power. That's right. They produce less heat. Okay? Less power, little power, less heat, which means less energy, and this is considered a very important issue. Mobile phones, tablets, laptop, and portable devices, games, all uses LCD screens. So all of them are still using LCD screens, not LED, what we discussed before. Okay, let's move further. Advantages of LCD screens. Okay, very efficient. This is now general saying. LCD, even it was LED technology or CCFL technology. Both of them considered very efficient, low power consumption, comparing with CRT. Okay, we are comparing it now with CRT. So, very efficient, low power consumption. CRT, a very high lower consumption, a very high power consumption. Lightweight device, because it's thinner than CRT, so it's lightweight than CRT. Okay, than CRT. Unlike CRT monitors, do not suffer from screen image burn-in. That is a permanent image burned into the screen due to unchanging images over a period of time. Which means if you fix the image, you make pause, for example, you are watching a film and you make a pause. If this image will continue for a long time, it causes damage to the screen, the CRT type. But for the LCD, there is no problem, even if you pause the image for a long period of time. Okay, so it is thinner, it is low weight, and low power consumption, and no image burn-in. Over what? LCD over CRT. This is the question of comparison between LCD and CRT. Screens can be made in large variation of size. While CRT, there are a limitation because, as I told you, cathode ray tube, the tube, that vacuum tube, should be with a specific dimension, and it is too hard. It's hard to manufacture with different sizes. It could be done, of course, but not easy as much as like a smartphone or tablet or laptop. So CRT it is not it will not work in this situation. Do not suffer from flickering image, unlike CRT. This is it's like a radiation that comes from the and reflection of the surrounding on the screen. So because of that, it is better than CRT. Very sharp image resolution, allow a vast range of colors, produce low electromagnetic fields compared to CRT. As we mentioned, because CRT is working with a high voltage, and it works with the beam of electrons and a phosphor anode. There's a lot of energy there, so of course it will be produce a very high electromagnetic fields. Okay, while LCD does not do this. Okay. Disadvantages of LCD. Let's see now disadvantages. Color and contrast from various viewing angle can be inconsistent, which means if I will look from this angle degree, I can't see the screen. You see that? And now it's not clear for me. So this is, while with CRT monitors, this is not an issue. Motion blur is a common issue. Also, motion blur, you know what, that it could be during the motion you will feel some inconvenience while watching the image. Lower contrast than CRT. So the contrast in CRT better than LCD monitors because it is harder to produce a deep, rich level of black. Yes, we will talk about it, which means we can't produce with LED technology a rich level of black. Okay, will be discussed later because the backlight all the time should be on, cannot be off, because if you want to produce another colors, the light should be on. So to produce the black, it is very hard. So sometimes it comes like a deep level of gray, not a pure black. While with the CRT monitors, there is the presence or absence of the electron beam will produce it as black or as white. LCD can have weak or thick stuck pixels, which are permanently on or off. So some pixel may be improperly connected to adjoining pixels, rows, or columns. As I told you, each pixel should be connected with it comes with a connection to light it in or to light it off. Maybe some problem with connection of this LED with electricity, it makes some sub-pixels not working, so there is no light. So the pixel will not work properly, that will not give the right color, while this could not be happen with the CRT monitors. The LCD panel may not be uniformly illuminated by the backlight, resulting in uneven intensity and shading over the screen. I will show what's the meaning of this. So as the panel may not be uniformly illuminated, which means maybe the LED, the grid of LED or the fluorescent tube, maybe the spread, the illumination not equal on the all parts of the fluorescent tube, or not all the LEDs have the same illuminity. So this will cause that the colors that coming into the pixels, the subtitle or subpixels will not be even. which produce uneven color distribution. I will show you this in video also. This point will be more clear when you will watch the video. So again, we have, as we mentioned, okay, the viewing angle. We have a problem with the viewing angle. Motion blur, we have a motion blur. And we have not very rich black level, so the lower contrast, it will be lower contrast than CRT monitors. Sorry. Lower contrast because of the poor level of black. Then we say that have weak or stuck pixels, which means permanently on or off. Some pixels may improperly connected, so it will be off all the time. This means it will be off all the time. So this is cause a problem in the whole picture. The LCD panel may not be uniformly illuminated, so it will cause what? The back resulting uneven intensity and shading because the lack of uniformly illuminated. Sorry. Okay, next. Okay, before going to touch screens, let's watch this film that maybe will make the picture clearer for you about the LED and LCD technology. Hopefully you will enjoy it, and I hope will be here. Yeah, right. Let's see. So as I told you, this is how the technology improved from LCD, LED, and the last one, organic LED, but it is still out of scope. So let's see the market. About 40% of the market is still LCD monitors. As I told you, this is the lid, the first lid that we covered. We have tiny, very tiny pixel with 3 sub-pixels, each pixel red, green, blue. But because the limitation of the manufacturing, so it's very tiny. To produce 4K, you see the comparison with the ants, the size. So to produce 4K resolution, I need to make this sub-pixel 1/3 of millimeter, which is very hard to do in real situation. So for very large screen, 4K or 8K, it's hard. So it's replaced with color filter. Instead, this is not a LED, this is a filter. So it's a type of glass with different, this is a pixel, each pixel with different colors. And this is the backlight we are talking about. It is white lid. This white lid will illuminate it goes through the filter to the screen. Either if it's on, it will be white. If it's off, it will be black. But if I want to, for example, if I want to, this is the backlight, the lid, and this is the filter color, and this is the screen that we can see. So if I want to, if it is on, it will be white. It goes through all colors. So it goes all colors, so it will be white. If it is off, so there is no color here, no light here, so it's be black. But if I need a different level of brightness, in order to give a different level of shading of colors, okay? So to change the shading of color, for example, I need light green, dark green, and different levels of greens, different levels of red, different levels of blue, in order to give me different variation of colors. In order to do this for each pixel, we have to change the brightness of the light coming to this filter. How we can manage this? So I have to change the the intensity of light coming here. To reduce the intensity of light, I will use something called optical sheet, which is the crystal liquid. We have here a crystal. Each pixel has a crystal liquid. Each crystal liquid, this is the light beam will go through this type of crystal liquid, and it will bend the light. Bending the light will cause to make to lower the intensity of the light. Then this will be come through this pixel, for example, the red one, and the shading will be different from, and as a result, this will apply for all pixels, so different intensity of light passing through the crystal liquid. Because of that, we name it liquid crystal display. This it comes from this crystal liquid that change the intensity of light coming from the backlight into the color filter, and then at the end it will be seen on the screen. We have here something called polarizers sheet. Those polarizers sheet, it will control the beam of the light. It will control the beam of the light, and to make able to control to be more controllable, which means you will see now what I mean by this. Let's continue. Hopefully this will work. Doesn't? Okay. You see the light, as you know, it has electric field and magnetic field and direction, and they are perpendicular for each other. But for simplicity, we will just describe the electronic field that passes through the light. So to make this is unpolarized, and in all directions, as you see, the light goes in all directions. In order to make it goes in one direction, I will use the vertical polarizer, so it will pass only the vertical angle, which is 90 degrees of the light. It passes through the crystal, as I told you, and the crystal liquid will, or liquid crystal, will bend the light to change its intensity, okay, angle, rotation, sheet. So this is the key. This is the secret of LCD monitors. It will pass through it. As you see, it was vertical. As you see how it bends, so it goes through the sheet. Maybe it become horizontally. Then it goes to the other filter as a fully horizontal. So full intensity output. This is the full intensity output from. I will make the angle rotation 90 degrees. From 90 to 180. So the rotation will be 90 degrees. This is the produced in full intensity. If it is vertical, it will be a zero intensity. Okay. So this is the main use. As you see, this is our pixel with different colors. The light passes through it. Through the crystals, it bends in different directions, and it gives us different shading. You see how the pixel changing its color accordingly to the intensity of lights coming to those subpixels. I think this is clear enough for you to understand the technology behind LCD monitors. If you zoom in your phone, you will see such pixels. You see red, green, and blue. This is gray, and this is yellow. Because of different intensity of light, it will give us different shading. Hopefully you enjoyed this film and hopefully understood LCD, LED technology, how it works, and the difference between them. I hope you enjoyed this class. See you at the next one. Thank you.